Hello everyone, welcome to this video by Data Sense. In this video, we are going to discuss the Python coding test 1 that we actually gave as an assignment from July 19th and July 18th, 19th and 20th to you guys. There are total of 10 questions in this test and you were asked to submit your solutions by emailing us. So we have received around 25-30 emails so far. I'm expecting that others will also send me by the deadline finishes, but in this video I'm going to discuss the solution to each of the question. Right, so it doesn't matter if you were able to solve the questions properly or not. It's my humble request that watch the solution, that how I am doing to how I'm actually solving the Python questions, right? Because see, questions anyone can solve. Problem is building an architecture. As I always say this word, building an architecture is very important. So whenever you look at the question, first visualize things in mind and then let's start coding. Okay, so without any further delay, I'll start with the question number 1. So the question number 1 says, given the following nested list, write a Python code to extract the number 10 from the nested list. So you are given some nested list. If you say data equal to this, and if I see the number 10 is present here, and they are asking me to basically extract. How do I extract? So if you see this is a list, right? And we know how, we can do simple list slicing to extract the number. What is the challenge in this question? The challenge in this question is that you don't know, I mean, in which nested list is 10 lying in. That is the biggest problem here. That, I mean, you by just visually looking, you cannot tell that okay, it is present in the third nested list, then inside that second nested list, something like that. So that is something that we need to crack here. That is the main if intuition here that we need to build. And I have told you guys already the approach to this to solve this particular type of question, but I will still start with that. So remember, if I remember that any list, okay, so for example, let's say any list, as I mentioned, it can be of multiple types. It can be a element in list. So what is an element in list? I already told. For example, 1 2 3 4, these are simple elements. After this comes list in list, list in list. So what happens in list is that you have a nested list. For example, let's say 1, then you have 1 2, and then you have again 1 2 3. So this type of thing is present in this list. Now you don't know actually how to slice this down. So this example is an ideal basically perfect combination, perfect example of this particular type of question. So how do we build it? The first step that we have to actually take down is, just give me a second, let me correct my pen. So okay, yeah. So how do we do is, so we take the list, we write down the list at the start. So we create a tree. If you remember, we create a tree like this. Okay, and this is my initial list. For example, let's say my initial list, whatever is given to us. So in this example, we are given a data. Now any list, we want to get the first prime. So we want to get the primary element. Want to get the primary element or list what is present inside it. So what we do is that we have to simply do we slice it at various level to see, like data 0, data 1 and 2 and so on, to see what is my initial tree. Right, how is it looking like here? So for example, in this particular question, I don't know. So what I will do, first of all, my first step should always be to do a data 0 to see how things are populated with there. Now if I do a data 0, I see that okay, 1 2 3 4 5. So till this point, these are in a single list. These elements are in a single list. Then if I see, so I see 1 to 5 are present in list 1. So I see that 1 to 5 are present in list 1. Of course, there is a nested list inside, but we know that they are present inside it. Now if I do a 1, what do I see? I see 6 to 11. Of course, 9 and 10 are nested in it. Then they are further nested in 7 to 8. But 6 to 11 are in another list. I see that 6 to 11 are in other list. Okay, and let's say I do list data 2. So what do I get? Data 2 with I get 12 to 14, which is still here. So these are my last list. So 12 to 14. 12 to 14. Now what is my question? I need to find 10. So which list will I further break? I will have to break the list 1. This particular list I will have to break further. Okay. So what will I do? Now similarly, just like I did data 0, I will do a 0 to this list as well to see how it is breaking down. So first of all, we had data 1 to get this list. Okay, we have this list. Now this, if you see this one element, there is a nested list and there is third element, and we see 10 is somewhere entangled here. Okay, so if you see list 2, how is it breaking down? It is breaking down as 6 is here, then it is 7 to 10 in this list. Okay, 7 to 10 is in this list, and then there's a list of 11. Okay, so this is how things are basically breaking. Now let's try to further deep dive. Now we don't need this, as per the question we want 10, so I don't need this, I don't need this. So what I'll do, I'll further break this particular list down. Okay, so 7 to 10, 7. Let's see how these particular elements are listed there. So if I do initially a data 1 and then I do a data 1 as well, so I will get access to 7, 8, 9, 10. Okay, now here if I see again, this is 7, 8, 9, 10. This is like, how is it splitted? 7, 8, 9, 10. So which list do I need? I need the third list. I need, so it will be 0 here, and then it was 1 here, and then I need to find 0, 1, 2 here. So I need to pass a 2 here. Now when I do 2 here, I'll get access to third element here, third element in list. Okay, and now when I close it, sorry, it has to be 2, not 10. Okay, 9, 10. So I have got access to 10 and 11 now, or 9 and 10, sorry. So I don't need these particular two things right now. I can remove them. Now I want to break down to this, to basically 9 and 10. So I have to break them into 9 and 10 to access them. So how will I do that? It's simply 0, 1. So I'll provide a listing of 1. Okay, and this is the code which is required to fetch the element 10. So now if I just look at this particular code, how does it look like? That I started with data 0 and I moved down. So I started with data 0. And once I moved down this, I had to do a 1, and then I had to do a 2, and then I had to do a further 1. And this is how I fetch the value of 10. So this is the mere coding that is required. So I hope this solution is clear to you guys. It's very simple, but you need to understand the architecture, that how are we going to build this solution around. So that is more important, rather than, because you don't know how things are entangled here, right? So this is the best approach, that first of all you break things like this in a tree, and then you will be able to understand it much better. So let us now solve the question number 2. In the question number 2, we have given a following nested dictionary. Write a Python code to retrieve the +4 value. So +4 is a, if you see in this dictionary, it is a key, the value associated with this particular key. Now the problem is that it generally, what we do, let's say we have to get, for example, let's say if we have to get access to a key, what we do, person, let's say in a dictionary, and we just name it +4. Okay, and if I just bracket close it, let's see what do we get. It will give an error, because +4 is not the key in the primary dictionary. Okay, it is a nested dictionary. So how do we, so there's a concept of primary dictionary, and it is just like we did in lists. So there is a primary dictionary, then there is a secondary dictionary, and then there are things so on. So there is like primary dictionary, and then there is secondary dictionary. So what we need to identify, and then there can be tertiary, there can be like, we can keep on adding things as we go. So the point here is, how do we actually access things inside this. We know how to access things inside primary, but how do we access inside secondary or tertiary? That is the main question here. Okay, this is similar to, I will say, similar to the list question that we first create a tree. So for example, what we will do is let's create my dictionary here. This is my dictionary initial. Okay, now this dictionary, initial dictionary, will have some keys and key and value. So for example, let's check out. If we click on this part, we see that this curly braces match with this one. So this is the whole dictionary. Now if I click on the second last, we see that this is matching with this. So it means that all of this part is clubbed inside a single thing, which means this is just a value of this address. So there are three things: name, age, and address. So how is my primary dictionary? Like, there is name, there is age, and there is address. There are three things here. Okay. So I need to access the value. So I need to access the value of address. Okay. First, I need to access the value of address. And inside that, I need to address the value of like whatever thing information I need. So that's how we will build the architecture. So how do we get access to this? So what will we do? First of all, we will write person, and we will just write address. So what will this give? It will give me a new dictionary which has city New York, and it has a zip code. So it has a key of city which has value New York like this, and it has a key zip code which is further nested dictionary. Okay, so if I further break this down, there are two things in this particular dictionary. In address, I have city and then zip code. So I have a city, and then I have zip code. Okay, and zip code is further, if I see, it is further. So how do I get access to zip code? Then what will I do? After this, I will add zip code, and I'll get this. So I got the final dictionary now where I need to. So there are two elements, main and plus. So in this zip code, there is a main, and then there is a plus. Okay, so how do I get access to plus? I will just simply pass the value or the name of the key which I need to access, that is plus, and it will help me fetch the value. So this is just a slice. Just let me +4. Sorry, it's +4. So this is just a basic slicing technique question, a simple how do you access things in a nested. I am sure most of you were able to solve this, but if you were not able to, or even if you were able to, just build this tree always. Whenever you see nested things, they're very easy to understand when you build trees like this. So I hope this solution is clear to you guys. So welcome to question number 3 now. This is a very interesting question. Actually, it will test you on few of the concepts. The question says use a while loop to sum all the even numbers between 1 to 100. Okay, so I mean, so far you would have done use a while loop to sum values, some numbers from 1 to 10, some numbers from 1 to 100. But here there are few things that sum all the even numbers. So this is the criteria that we need to fulfill. Okay, so now let's go back to a diagram. So what is happening that so this is, let's say this is that sum that you are trying to build. So let us say this is the sum that you're trying to build. Let's say this is a container. Okay, so what happens that you pour all the numbers to this 1, 2, 3, 4, and all that. So you are basically putting all the possible numbers from 1 to 100 into this number. Okay, now what is happening? This is doing first step. First is it is filtering yeah, so it is taking sum of only even numbers. You have to create a system like this. So what will be the steps? Here the steps will be: first, collect all numbers. Step will be to collect all numbers from 1 to 100. Okay, second step will be to filter even numbers. Okay, and then the third step will be to sum those even numbers. Okay, sum even numbers. So this is our solution will look like. We'll have three steps in our code. First, collect the numbers from 1 to 100. Second, filter even numbers, and then we do sum of all those even numbers. So if I remember in a while loop, what happens? We have to initialize something. Okay, and then we have to write the while condition, and then we have to write the code block. This is the basically the structure of a while loop. Now how do we do that? We keep our sum equal to 0 initially, right? We keep our sum equal to 0 initially. Now whenever a number comes in, we check whether if it is, so we basically create a test here at the start. If it is even, then we will pass the number. If it is false, if it is not even, we will cross that number. Okay, so what will happen? When 1 comes, it fails the condition, it will not come. When 2 comes, it passes the condition, so 2 will come here, then 4 will come here. So how will sum build? Sum will build from 0, then sum will become 2, so then sum will become 4. So like 4 to just 6. So let's say initially 0. So when 2 comes, it will be 2. When the 4 comes, it becomes 6. When again 6 comes, sum becomes 12. Okay, and that's how this thing will go on. So what is happening? If we have to initialize, my initial sum has to be 0, correct? I have to initialize this value of this bucket has to be initially 0, sum equal to 0. Okay, now the second initialization, if you think the numbers are varying from 1 to 100, okay, so what we need to do, that we need to put a number I initializer. It can be anything, you have to put it as 1 initially. Okay, because numbers are starting from 1. If they ask that no, the numbers are starting from 0 to 100, then we will do I equal to 0. So initialization comes from there. Now comes the while condition. Okay, so what is our while condition? Our while condition is that our number has to be less than 100. Sorry, up to 100. So what we'll do, while I is less than equal to 100, we will run this code. Okay, so this will be my while condition. And in the code, what I will do, I'll do if the number is even. If the number is even, then we do sum equal to sum plus number. We will do sum is equal to sum plus number. Okay, and if the number is not even, we will pass it. If the sum is not even, we will pass it. So this is the whole architecture of this particular question. How we built initialization, how we built while, and how we built this particular code. So now let's start doing this particular question. So what we do, first of all, we need to initialize. So what we do so let's initialize. We need to have a sum which has to be equal to 0, and we need to have an I which has to be equal to 1. After this, we'll put the while loop, while condition. So what is this? While I is less than 100. Okay, now comes the coding part. So what we want to build, the I has entered. Now we want to build two things. If I percentage is if I percentage 2 is equal to 0, which means if the number is even, right? So what do we need to do? Sum is equal to sum plus I. Okay, that's what we are doing here. And after this, what we need to do? We need to do increment I is equal to I plus 1. Okay, and now I need to print sum. Will this give me result? Let's find it out. The logic so far we have been doing. So we have built like while I percentage 2 equal to 0. If the number is even, I have to sum, and I am adding it to the value. Now if I do the sum, let's see if we are getting a result or not. So we are not getting a result. So there is something wrong with our code. So let me figure out. So let me go to the architecture once again to understand this particular concept. This is a very important. So basically the issue is with the placement of I equal to I plus 1. Okay, so if that shall be placed inside if block, or if it shall be. So basically if I do it like this, then this code let me restart the kernel. So now if I do like this, I'll get the value 2450. Okay, but if I move it inside, it is not going to give me anything. So if I do like this, I'm not going to get anything. But if I do back, and if I just restart something, there's something wrong with the Python book, but it's fine. So if I restart the kernel, so what happens, it will run like this. So now if I do, I'll get 2450. The problem with this is that how do we decide where should I place this? Now let's come to this particular concept. So when we are writing down this while condition, let's say while I is equal to, while I is less than 100, okay, less than equal to 100. Now we are putting an, what we are doing, we are summing even numbers. Because when we are ranging from 1 to 100, we will have even numbers as well, we will have odd numbers as well, correct? When we will increment, we will have both even numbers as well, and we will have odd numbers as well. So what we will do is, if we have the condition, if I percentage 2 is equal to 0, let's say the initial condition for checking if the number is even. What do we do? If the number is even, I need to sum it, correct? What if the number is not even? If the number is not even, I need to just increment it by 1. So for example, if the number is even and if the number is odd, what are the operations that I need to do? When the number is even, I need to do a sum, okay, and then I need to increment by 1. I need to increment by 1 so that my loop takes the next value. And when the number is odd, I don't need to do sum, I just need to do increment. Okay, that is the thing. Now if I write I equal to I plus 1 here, what is the problem? Problem is that if the number is even, that is fine. If the number is 2, okay, it will sum it and it will increment it to 3. Perfect. Now I becomes 3. Now I will go back here. Let's say I comes here as 3. Now will I satisfy this particular criteria? No, I will not satisfy, because 3 is not an even now. 3 is an odd number. So it will come out of the code, and you have not provided anything what an odd number should do. So you have not provided that it should increment by I equal to I plus 1. Okay, so that's why you need to move this thing little out of the while. You have to anyways always increment the value. Doesn't matter if it is even or odd, you have to always increment. If you see, increment step is present in both. So you don't need to write I equal to I plus 1 inside the if block. You have to keep it in parallel with if block. So that is, it is a part of the code, and that is called the indentation problem. So once you do that, you will get the value as 2450. But if you do not do that, you will not be. So for example, let's say if we just do this, we will not be getting the value. Okay, so this is the main thing that you need to understand. Your final code should look like this. And this is the part where you need to focus on. There a lot of students would have defaulted here. So you need to understand that I is varying from 1 to 100. Okay, 1, 2, 3 up to 100. For even condition, I have created a syntax that, okay, if the number is even, I'm summing it. That's fine. But what if number is not even? So so you have to do an increment here in the outside of it. Okay, and then this will particularly like execute, and it will return your number, like whatever number you want. It will give you the sum. So 2450, you will get it. So I hope this explanation is clear to you for the question number 3. So welcome to question number 4 now. So how are we going to, so the question says that given a deeply nested list, write a Python code to flatten this nested list into a single list. So we have a nested list like this, and we have to flatten it to a simple list like this. So basically we have to get all the elements. Now if you remember, we have done a similar question, I won't say the exact question, where we used to iterate over nested list and get access to elements. Let's try to do that first. Are we able to solve it? For example, let's say do a for a in nested underscore list. Let's say I do like this. Okay, now if I do something like this, my first step will be I'll get the nested list like it is. Now if I do another for b in a, okay, and I do a B. So if I see, I get an error. I get an error like this. It says the int object is not iterable. The problem is that when you do for B in A, this is an integer. This is not a list. So it can iterate over this because this is a list, but it cannot iterate over an integer. That is the property that integers, you cannot iterate properties over there. So a direct list comprehension will not be working here. So that is the catch in this question. If you're thinking that it will just work like that, I mean, of course, I will not give you a similar question which I have already given you earlier. So there must be a catch in this question, that how do we solve these kind of questions. So this is a very beautiful question. I will like you to please watch this video till end, at least this solution till end, that how are we building. So first of all, we'll start building the architecture of this question. So what do we have? We have this, we have this, let's say, list here. So how it is like this? This is 1, and then it is 2, and then it is 3, and then it is 4, and then it is 5. So it is built like this, list inside list, list inside list. Okay, and we have to flatten it to like this, let's say flattened list, which is technically 1 2 3 4 5. We want this 3 as well. Okay, so we want to build like something like this. The point is, we cannot, if we cannot iterate over this like we used to do in the list comprehension, so we cannot apply list comprehension here, right? We cannot apply list comprehension here. So what do we do here? A method that you should be doing for this particular question is, let's start from the start of the list. Let's start moving from left to right. So let's start from left, and so what we do, that whenever we hear an object, whenever you hear something, suppose when I move from here, the first element I face, so whenever I go to A, I face two things. I can either face an integer, okay, or I can face a list. I can face a list. Okay, so now if I compare with my final, if I compare this with this, I see that if you find any integer, you just copy it in this file. So basically, let me create a simple flattened file which is equal to a blank list. Okay, so if I ever encounter any integer, what I will do, I'll basically copy and paste it to this blank. So I'll pop it out. So what I'll do, I move here, I pop out the first element. Okay, I pop out. So I'll basically pop it out from here, and I will check if it is an integer. I will move it to here. Agreed? Now, so let's say we go to the step 1. Is if we pop it out. Now what is my A after this? My A will be 2, 3, 4, and 5. Okay, it will be like this. So what I did, I popped out. So step 1 was I pop out element 1. Okay, check if it is an integer or if it is a list. If it is an integer, I will move it to copy it to, you'll copy it to the flattened file, flattened list, or whatever it is, this flattened list. Okay, we'll copy it to this. But what if it is a list now? Now what happened now? So okay, I did the first element, it has gone here. So now my list is this. Now I am encountering this particular, here is a list. So how do I treat list? How do I basically treat list here? So what I'll be doing, it's a very interesting thing actually. So I'll pop this list out. Okay, so what I will do, whenever I come to this particular point, I'll pop this list out. Okay, I'll pop out. Okay, so once I pop this out, my A will become blank here. So here my A becomes blank. Okay, now what I do, I add this list. So now we have a new list, for example, temporary, that is L is equal to 2, 3, 4, and 5. Okay, we have something like this. Now I have this, when I pop this out, I get a list like this. What I do, I do A plus L. Now if I do A plus L, what will be my my new list now? So if I do an A plus L, my new list will look like So what happens when we add two lists? It will, blank will remain blank, and then I will have 2, I will have 3, I will have 4, and I will have 5. Okay. So my A gets updated to this. Now again I start moving from left. Now I move to this. If this is an integer, now I will move 2 back to initial my where my final front list already had 1 in it, right? So I will add it here. So my front list will become, flattened list will become 1 and 2. Okay. And now again, when after popping out, my A will become 3, 4 and 5. So no, not like A. So my A will become like 3, then 4, then 5. Okay. And this will be a list like this. It will be a list like this. So now whenever I move again here, I see another list here. I see another list, correct? So what I will do again, I will use the same approach, that I pop it out. I'll pop it out. And what is this? This is again a list. So if it is a now after popping out, A becomes blank again. And what is my intermediate list? Intermediate list becomes 3, 4 and 5. Okay. And now what I do A plus intermediate list again. So it will become 3, 4 and 5. Okay. Now see, my again 3 has become an element, integer basically. So what I will do, I will again start from the left. Now again I see, because this is an integer now, so I will move back, add it to my my flattened list, which was previously was 1, 2. Now it will become 1, 2, 3, and I will keep on doing till my A is empty. Okay, so till my A is empty, I am following this step. And what will happen after iterating through all the steps? I'll get 1, 2, 3, 4, 5. So this is a very interesting case of while loop, where we are doing some pop out, where you're doing some while loop condition as well. So this is the architecture of this particular question. Let me just rephrase things once again. Okay, so that it summarize things again in a single, I will say in a single view, so that you guys can understand. So what I'm doing, what is my solution architecture? Let's say I get a list like this. I have a list 1, 2, 3, 4, and suppose something like 5. Okay, I have something like this. So what I'm doing, my step one is pop out the leftmost element. So pop out the leftmost element. Okay, leftmost. So what I will do, A, and I like dot pop something 0, will pop it out. After popping out, what we are checking, check if it is an integer or if it is a list. Okay, if it is an integer, so you will create a flattened list, which is initially blank. And if it is an integer, you will basically append to flattened list. Okay, you will append to flattened list. If it is a list, now if it is a list, then what you do, you pop that out. Okay, you pop out, and then what you do, you basically add list again, add list back to it. Now when you do adding back, what happens, that A will become is equal to blank plus intermediate list that we created. And what will happen, that 2 will again, now in that 2 will become an integer. Okay, so again it will become like 2 and 3 and so on. And then you step 8 is repeat process 1. So this is what we are doing here, repeat process 1. So the main thing here to understand, the thing that is to capture here is this particular part, that because you have something here like when you had a list like this, 2 and 3 and 4, let's say I'm using a small example. Okay, the main thing is to convert this particular list into something like this, 2, 3 and 4, so that we can take this element out and we can copy it to my flattened list. So this is the whole intuition behind this particular question. It's a very interesting question, I will say. So we will start the coding now, but this is the whole architecture. So we will be writing some, I will say, some advanced codes here, and not advanced, I mean basic. It's a loop only, but we will let's see it how we're going to do. So we have a nested list. Okay, what we are going to do, we create a flat list. For example, flat list equal to, initially this list is blank, which, as we discussed, this list has to be blank, which we just mentioned here. Okay, now what I'm doing, I'm just keeping a copy of this nested list. So what I do, for example, let's say list 1, let's say I'm just taking a copy of it, is equal to nested underscore list, and if I do something like this, it means I have just copied it. So let's say L1, let's name it L1 so far. Okay, now I'm just preparing myself. So if I just do a print L1, just let me cross check if I'm getting it. Yeah, okay, I have my this list. Now my process starts. So I have to write on a while loop, basically a while. Now what is the while condition? So till when I'm iterating, till my A becomes empty. Because what I'm doing, every time I'm popping an element out, every time I'm popping an element out, popping an element out. So till my A becomes empty, correct? So what we can do, till my L1 is true. You can simply write till my L1 is true, or you can just make it like while L1. Okay, you can just keep it like this, while L1 true or while L1. It will be easy. So what is our first step? So let's go. What is our first step? Pop out the leftmost element. So we are popping out the leftmost element. Let's call it let's say leftmost, or let's call it item, for example, is equal to so it is my L1 dot pop, and I am popping out the 0th element. Okay, so I popped out the first element of this. Okay, I hope it is clear till now. Now what I am doing here, the next step is I have to check whether the item is a list or an integer. So I will do if type of item. So for example, if type of item is equal to list, okay, if it is equal to list, if it is equal to list, so if type of item is list, so what I'm doing, remember, if type of list, I'm adding it back to my previous thing. So if type is list, I have to do that. So L1 is equal to L1 plus my what is my just a second, so item, which, because I popped out item. Okay, and if this is not this, if else, like for example, when it is an integer, so what I will do, that I will append it to, else what I'm going to do, flat underscore list dot append, and I'm going to append the item. If it is an integer, I'm going to append it, otherwise I'm going to just follow the process. Now if I do, let's say, print flat underscore list, now if I do something like this, so I get this flattened list. Now let me just flatten list. So what I'm printing here, so let me just remove this. Now if I run something like this, I'm getting flattened list 1 2 3 4 5. So this is the approach here which you need to follow. It's a basic, it's a very good I mean, it contains while loop, pop, those kind of intuition, but you should definitely try this out and let me know if you're able to understand this or not. So let us come to the question number 5 now. The question number 5 is a little advanced question. It says that you are given a list of sets, and for each set contains integers. Write a Python code that finds the elements that are common to at least half of the sets. So how many sets are there? 1 2 3 4 5. Okay, there are 5 sets. I want to find those elements which are present in at least 3 sets inside this. Okay, so there are so let's let's draw the architecture. So we have a list equal to set 1, set 2, set 3, set 4, set 5. Okay, and we have various elements. For example, let us say we have 20 elements. Okay, we want to find those elements which are present in at least 3, at least greater than equal to 3. Okay, their frequency is greater than equal to 3 if I talk about this. So how do I go about building this? Now tell me, if I can create a chart like this, if I can create a chart like this where I have the element, for example, there were 20 values, right? So I can have those elements here, and their values and their frequency, in which set, how many sets are they present, in how many sets are they present, or I say frequency. Okay, so for example, let's say element 1 is present in 2 sets, element 2 is present in 1 set, element 3 is present in 4 sets, element 5 is present in 3 sets, and element 6 is present in, let's say, 4 sets again. If I can create a chart like this, then it becomes very easy for me. All I need to do after creating a chart, I need to filter out elements if frequency is greater than equal to 3. So this is what I will be building in my code, right? I have to build a solution like, I have to build a solution overall like this. So how do we do that? First of all, we create a dictionary, a blank dictionary. First of all, we'll create a blank dictionary. Okay, and then what we will do, we will iterate every time we'll iterate in this and this. Okay, and we'll check if an element is present in this one or not, on this one or not, or this one or not. Every time we encounter an element, we will increase. So if we encounter an element for the first time, we will add to the dictionary, or if we encounter an element for the second or any other time, we will upgrade its frequency by 1. And in the end, we will create a table like this where we will be filtering out. So let's just start coding this particular question. So let's say we have this list. So what I do, that I create a blank frequency table. Let's say frequency, which is the dictionary that I want to create, a blank dictionary I have. Okay, now what I do, let's say for sets in sets list. So I'm trying to access all the sets which are present, which are present here for sets in set list. Okay, now inside each set, what I'll do for s in sets. So what I did, first of all, I accessed sets inside the sets list, and then for in each set list, I'm trying to access an element. Okay, so now what I will do, what I will do that, for example, let's say if s in frequency, so if my s is already present in frequency table, means we have encountered this somewhere before this, right? If it is present there, what I will do, I will do frequency, and in frequency I have to name that s. Okay, and I'll increase its frequency by 1 if we have already seen it. Else what I will do, frequency of s, if I'm observing it for the first time, what I will do, I will give its frequency as 1. Okay, now if I just do a print of frequency, let me see what the frequency shows me. So it will show me the element which is present. So like 1 is present in 2 sets, 2 is present in 1 set, 3 is present in 1 set, 4 is present in 2 sets. Like this kind of frequency I have. Okay, now I just need to create, I can create a basically, let's say a common. So what I do, let's say I create a list. Okay, let's do something like this. Common is equal to, we create a dictionary comprehension or list comprehension. So we do key for key comma value in frequency, and frequency dot items, basically. Yes, in frequency dot items, if we have done this coding earlier, if value is greater than equal to 3. Okay, now if I have this, I'll get created now if I do print common. So if I do this now, I get 5. So 5 is the element which is getting repeated in at least 3 times. So this is the basic syntax of this particular code, where you have to print elements which are coming at least greater than at least half. At least half means they're coming at least 3 times. So that's what we can do here. So I hope this solution is clear to you guys. So welcome to the question number 6 now. The question number 6 says, write a Python program using a while loop to reverse the digits of a given positive integer. So for example, you have an integer 1, 2, 3, 4, 5 and you want to reverse it. So basically your final number should look like this, like it should look like 5, 4, 3, 2, 1. Okay, so how do you reverse it? So there can be, so like you can convert this to string basically, and then you can but that is a very like weird way to solve it. But we'll solve it using proper like good logic here, so that interviewer can also understand that you can actually solve Python questions. So for example, let us say you have a number here. So let us say the number is 1, 2, 3, 4, 5. Okay, now let's try to build the intuition around it. Remember, I have already spoken that how numbers are framed in like how computers store number. So there is a unit digit in any number, there is a tens digit, there is hundreds digit, there is 1000 digit, and there is 10,000 digit. That's how things go. So in this, what is unit digit? That is 5. Tens digit is 4. Hundreds digit is 3. Thousands is 2, and 10,000 is 1. So if you have to write down the number, what do you do? Your final number, if you know the digits at various positions, what do you do? So you'll do 10,000 multiplied by this one into 1 plus 1000 into this number 2. Okay, plus 100 into 100, that is 3, plus 10 into 4 plus 1 into 5. And if you sum, this will become 10,000 plus 2,000 plus 300 plus 40 plus 5. Okay, so this becomes 12,000 plus 300 plus 345. That becomes 12,345. So that's how the numbers are written in a in any number. The numbers are written in this format. Okay, but why did I tell you all this? So what is happening, if you see, when you reverse anything, so what happens that this, your unit digit will become your 10,000 digit, right? So unit will become your 10,000 digit. This will become tens, will become your 1000 digit. This will become your, it will remain your 100 digit. It will become your tens digit. It will become your unit digit. Okay, so what will it will be like 5 into 1000 plus 4, sorry, 5 into 10,000 plus 4 into 1000 plus 3 into 100 plus 2 into 10 plus 1 into 1, and your number will be so it will be like 50,000 plus 4,000 plus 321, something like this, and it will become 54321. That's how. So basically that is what is happening in any number. So what do you, how do you solve this? How do you basically solve this question? Let's try to identify that particular logic using this concept in mind. So what are we doing here? So when we have any number, n is equal to 1, 2, 3, 4, 5. Okay, let's say I have this number. So what will be my what will I do? Suppose, let's say I take the unit digit. I take the unit digit of this number. Okay, let me change the. So let's say initially my reverse number, I'm marking it to be 0 because initially I don't know anything. So I'm just initializing it to be 0 here. So what do I do? So when I pick the unit digit from this particular thing, so what I'm going to do is I'm just going to reverse this. So basically this last digit will be what? So if I see, reverse digit will be equal to 0 into, if I multiply this by 10, and it will be plus, what is my unit digit? Unit digit is my so 5. So this becomes my 5. Okay, and now for example this becomes my 5. So my presently my reverse digit is 5. Now when I do, so from this I basically I took my remainder dividing by 10, right? And I took this. Now I have 1 2 3 4 left here. Now again I sliced it. Basically I took remainder. Now my unit digit becomes 4. So what I do, it will become my reverse, that is reverse number into 10 plus remainder. Okay, so my new reverse number will become equal to this. My rev 2 will become equal to this. So it will be 5 into 10 plus 4. So it will become 54. So do you see that what is happening? First it was 5, then I added 4 to it. Okay, now similarly it is 1 2 3. Now I took 3 out. So what it will become 54 into 10 plus 3, which is equal to 543. So this become 543, and now the number remained was 12. And similarly it will become 5432, and till the number is not 0 I'll basically do 54321. So this is how the intuition looks like. We start with 0. Okay, we keep on adding. Here the quotient keeps on changing. So it from 1 2 3 4 5, it goes to 1 2 3 4, 1 2 3 4, then to 1 2 3, and it goes to 1 2, and then it goes to 1, and then it goes to 0. So this is downgrading. Here we are varying it, and we are increasing this number continuously. This is called we have already discussed this method, that how do you play with unit digit, right? That you need to think upon, and this basically comes with experience when you have solved a lot of questions. So now you must be asking that why are we using multiply by 10 only? You might be thinking that, okay, why didn't you multiply it by 100? The thing is that the logic that I've used, that I'm taking one digit at a time. And because whatever is present at unit digit, it has to be multiplied with 1, and we are adding it to the previous number, and whatever the previous digit is, it has to be a 10th digit, right? So that's why we did PV or into 10 plus unit digit into 5, and this will, when we iterate it over the process, I will get the number. So now let's go to the coding file first again. So what we do that, how is my so what are my iterators? So my initializers, if I see my unit digit, so let's initialize the values. Okay, so let's initialize. So I'll create a new number, n1 is equal to n. Okay, and or you can say, let's name it quotient is equal to n initially, which I used earlier as well. And after this I need my new reverse number. So initial reverse number has to be 0 because the number I have not provided it initially. Okay, so what I'm doing, I'm writing the while loop now, while QUO. Now remember, till when we are dividing it by 10? We are dividing it by 10 till we are reaching this particular point, 0. So while this number is greater than 0. Okay, so while quotient is greater than 0, so what I'm doing, what is my first step? My first step is to divide the remainder. So basically get the remainder by dividing this by 10, correct? So what I'll do, I'll take some simple thing, that units digit is equal to QUO percentage 10. Okay, this will give me my unit digit. Now what I'm doing, I'm adding this digit. So I'm technically adding this to my next number. So what is my next number? That is reverse. It will be equal to reverse into 10 plus, what is my number? My number is for 𝐞𝐢𝐿. Yeah, so I'm adding unit digit here. So my unit underscore digit, I'm adding this particular number here. Okay, and once this is done, what I'm doing, I am changing my quotient, because now it has to move from 1 2 3 4 5 to 1 2 3 4. So what I'm doing, 𝐞𝐢𝐿 will become equal to 𝐞𝐢𝐿 divided by quotient 10. Okay, and now if I do if I print REV, so I got 5 4 3 2 1, right? Now if I change anything here, so let's say I do anything, something like this. Let's say this so 0 no so let's say 2 3 4 5 6 7 8 9. Okay, and if I do like this, the number will be reverse. So it's a basically small, we have discussed this question in previous videos as well, that how this unit digit varies, how we divide by 10. You can refer to those videos as well. So it's a pretty simple question. It's how you initialize the values, what do you put in while loop. That is something important which you should be doing. So welcome to question number 7. Now the question number 7 says, write a Python program using a while loop that repeatedly sums a digit of a positive number until the result is a single digit. So it's very simple thing, that what it wants, that let's say you have a number like this, 1 2 3 4 5 1 2 3 4. You sum the digits. So 4 plus 3 7 plus 2 9 plus, let's name it 5. 5 plus 4 9, 9 plus 3 12, 12 plus 2 14 plus 1 15. It is 15. Now so the sum is 15 here. Because this sum has to be, they're saying sum has to be in single digit, right? In single digit means sum has to be less than 10. Now 15 is greater than 10, so we will sum them again. Now it will become 6. Now 6 is less than 10, so 6 will be the answer for 1 2 3 4 5. So similarly, like we have in this question, we have example of 9875. So how it will work, like 9875. Now if I sum 7 plus 5 12, 12 plus 8 20, 20 29. The first is 29. Is 29 greater than 9, or it is greater than 9? So we will sum it again. The sum will become 11. Now 11 is still greater than 9, so we will still sum it, and the final will be 2. Now 2 is less than 9, so 2 will be my answer. So that is what we are doing. We are doing sum multiple times. So this type of question, it's a good question. We have done the questions where we do the sum of a digit. So remember, we do the, how do we do sum of a digit? Let's say we have a number, for example 1 2 3 4 5, or 1 2 3 4. So what do? We create a quotient, we create a remainder. Okay, so we start with quotient 1 2 3 4 initially, and remainder is 0 because we have not divided. The step 1 is step 1. We divide this by 10, and quotient become 123 and remainder becomes 4. Okay, and so what I do, I create sum is equal to, I initialize a value sum as 0. Okay, here, and what I do, as things come here, I keep on adding them. So it will become 4 now. Now in next step, in step 2, so sum will become 4. In step 2, what will happen? Again divide by 10, 12, 3. Now 3 will go here. So 4 plus 3, 7. Okay, now step 3, again it will 1. Now 2 will go here. 2 will get added to this, the answer will be 9. And step 4 will be 0. And it will be 1, and 9 plus 1, it goes till here 10. So the sum of these elements is going to be 10. This much part we know how to do it, right? We have coded this multiple times. The problem is that I won't say call it a problem. I'll just say an addition to this thing is, we have to ensure that number is greater than 10. So technically what we need to ensure, if my final sum is greater than equal to 10, is greater than or equal to 10, then I repeat the whole process. Whatever we do here, correct? And if and if the number So when I repeat and I put a while loop, for basically I put a while loop while sum is greater than equal to 10, I keep on doing this thing, and the moment it gets less than 10, my loop will close and I will get the value of the sum. So that is the intuition behind this particular question, I will say. So you know how to do, how to sum. The only thing that you need to add, if you will need to add a certain while condition where you filter the application, where you keep on looping, keep on doing the sum again and again till your sum becomes less than 10. So let's start putting this architecture into the code. So what we do, that let us say, uh, first of all, we will have to reduce it to a particular number. So uh, let's say there's a number n. Now while while what I do, while this n is greater, so basically I'm changing this throughout, right? While this n is greater than equal to 10. Okay, so I will loop this. So what I'm doing, first of all, I have to create a loop initially. So to summarize, not to summarize, so basically create this sum. So I'll do sum of digits. Okay, I'll summarize it to be 0. Okay, I'll put it to be 0, and I will create a temporary variable meanwhile here, that temp that is equal to n, or we can call it, yeah, let's name it temporary, that is equal to n here. Okay, now what we are doing here is that while, so basically while the number is, so we'll sum this number till when, with the, or you can also call it QUO that we were doing earlier. While this QUO is greater than 0. Okay, while this thing is greater than 0, what I'm going to do is that I'm just going to add something to it. So sum is equal to sum plus, now what do I need to do? QUO remainder 10. So I'll be doing QUO percentage 10. That this is something we have done earlier as well. Okay, something we did here as well, that every time if the number is will keep on looping till the sum is greater than 10. Okay, after this what I have to do, I have to do QUO, I will basically is equal to QUO divided by 10. This is something that I have done. Okay, now this will give me the updated quotient. Every time my quotient will keep on varying, it will vary from 1 to 3 4 to 1 to 3 to 12 to 1 and so on. So that's what we will do. Now comes the main part, that once we have updated this, what we actually do is, because we are ensuring that while n is greater, what is n eventually? N has to be the sum of the digits here, right? So what we do, we write down a simple thing, that n is equal to sum. Okay, and what will happen, it will keep on looping. So whatever you do, whatever step you do here to create the sum, you store it in n. Now because we have put a condition while n is greater than equal to 10, keep on looping it. So it will keep on doing this until we get the value. Now if for here, let's say while n is equal to greater than 10, sum is equal to 10. Now yeah, so this is perfect. And now when I do print n, so this will give me the result, I think 2. Yes. So now for example, let's say I do anything, you can do any number. Okay, it will give you number only between 0 to 9. It will keep on adding things. So this is the basic concept, that you do sum initially first, right? And when you do the sum, you just put a condition, additional thing, that sum is greater than, while sum is greater than equal to 10, and you just pass on the value like this, and it will prepare the result. So let me know if this question is clear. If you still don't understand, let me know about this. Hi everyone. So now let's move forward with the question number 8. Question number 8 is little bit complicated. Although we have just solved the question number 4, where we had a deeply nested list and we just flattened it into a single list. It is an extension of that question. So what is there? You have a nested tuple here. You have to print the names of the people who have a salary greater than 70,000. Okay, so this is our objective. Now before we move ahead, let's just do a basic check, that how is this tuple segregated. So if I do nested tuple 0, so I see, okay, this is Alice, and then if I do 1, I see Bob, Charlie, okay. If I do 4, what do I see? Okay, so my fourth tuple is nested, then fifth tuple is nested, then sixth again, they are nested further. Okay, it's 4, 5, 6. So let me do a 6. Let me do a check. How is my seventh? Okay, my seventh tuple is even a further, like it's a further, like nested, right? This is what we are having here. Now let's try to build the architecture of this question. Okay, so this is exactly how we did the previous question. So what do we have? We have a tuple, okay, and in the tuple you will find it has it has further tuple. So it has a tuple inside it. Then it has another tuple in like a comma tuple one, tuple two, and so on. Then there is a nested tuple, and then there is another nested tuple which is further nested, right? Something like this we have. Okay, so we have these kind of elements inside it. Now my question to you guys is, what do we want to access? Do we want to access a particular element, or do we want to access a particular tuple? Question says that we want names of the people who have a salary, so we want to access a tuple, so that in those tuples where salary is greater than 70,000, we print their names, right? So this is what we need to do. Okay, the first step that we have to do, because this is a tuple and will have to like pop out few things. Remember in the fourth question we did popping, we like popped out few of the variables here. If we see in this particular question, in tuples you cannot do pop directly. So what we will do, first of all, our step is to convert this whole nested tuple into a list. Okay, so what I will do, I will create an intermediate list. For example, I'll create a list which is equal to nested underscore tuple. Okay, now if I just print list, let's see what it comes. So I have a list now. Okay, I have a list now. Inside this list, what do I have? So this is a list basically, and it has multiple probs. So now I have converted this into a list. Now this list has a tuple. It has a tuple. It has a tuple. It has a tuple. It has a nested tuple. So how many tuples are there? So 1, 2, 3, 4. 4 normal tuples are there, and 2 nested tuples, and 2 like 2 are nested tuples, and another one is nested tuple, something like this. Okay, so let's start going through the approach that we built in the question 4. That what we do, that we check the leftmost element of the tuple. Okay, so what we do the left. So we start from here. Okay, we pop out the leftmost element, and we ask ourselves, is it a tuple? Okay, because if it is a tuple, so it can be two things. So the element that I pop out, basically it can be a simple tuple. Okay, it can be a simple tuple, or it can be a nested tuple. Okay, it can be a nested tuple. So we will again do the same thing. If it is a simple tuple, then I just need to pass the if else condition, that if a tuple element, if salary is greater than 70k, then print name, right? So this one will be easy for me. Problem will come in the nested tuple. In nested tuple, what again, remember what we used to do? We used to add it back to my list. So when I pop out a simple tuple, I have been popped out. Okay, when I have only nested tuple remaining, nested tuple, and all those remaining, what I will do, I will pop the nested tuple out. Okay, and I will add it back here. So once I add it back here, it will become like a tuple, and then it will become like a tuple plus nested tuple kind of thing. So let me just so what will happen that we will suppose we drag this, okay. uh, so we have grays this, so we have presently this nested tuple, okay. Now when we pop it out, and we take, after popping it out, we just add it back to the previous list, so it becomes individual tuples, just like in our fourth question, right? And we will just need to again do the repetitive process, iterative process that we were doing, okay. So let me show you a very simple example of this so that you can understand. Okay, so let's say this was the case. So let's say after you remove the individual tuples, you have in your list, for example, you have a nested tuple. Let's say you only have one nested tuple. Where what is it like? So let's pick any nested tuple from here. So let's say this is the nested tuple. So there's a big tuple, and inside that there is two tuples. So it is like so there there is a big tuple, and inside this there are two tuples, okay. You are doing something like this, you have something like this left. If I compare with my this question, so I have an outer tuple, and inside this there are two small tuples, okay. So what will happen that when I pop this out, okay, when I pop this out, what will I have? I will have a tuple something like this, okay. So it will be like T1. So let's say it is T1, it is T2, okay. So I will have T1 and T2. And what will my list become? My list will become, it will become an empty list, something like this, okay. It will become an empty list. Or you say, now if I convert this tuple into a list, so what will this become? This will become a list of tuples T1 and T2, okay. And now when I add this back here to this list, so when I add this back here, so so I will have list is equal to T1 comma T2, okay. And now when I start to access the point from the left, I have a simple tuple in my hand, okay. This is what the intuition is about this. So let me just explain you once again this particular concept of when you have a nested tuple in hand. What you will see is that, let us say you have a so the question is either a simple tuple or a nested tuple. Now you have already taken the simple tuples out. Now you have the question of nested tuple. So what you will do, suppose let's say this is your tuple is equal to, you have, so let's say this is tuple 1, this is tuple 2, okay. This is T1, this is T2, something like this you are having, okay. So first of all, your step 1 will be to pop it out. You pop it out. When you pop it out, then you ask, is it a tuple or not? Yes, it is a tuple. So if it is a tuple, what you will do now your tuple will become an empty list, right? Whereas your intermediate tuple, it will be like this, and it will have subtuples inside it, okay, T1 and T2. Now you convert this back to a list, so it will become a list, and it will become T1 and T2, okay. And what you do, you basically move it back, you add it to this, so your tuple will become a list of simple tuples T1 and T2. And now you can access these tuples like a simple tuple, where you put the condition of salary and you pick out the name. So this is the whole concept of I will say the whole intuition behind this particular question. Now let's just start into the coding, because you'll understand once we do. So we come to the coding part now, right? We start the coding. We know so what we do will basically start in tuples, right? It's good to pop things from the back end, right? So we will be using just pop. I'll be start popping from back end rather than from the front end. It's totally up to you. So it doesn't matter in which order do you do. So let's start the code. Now we have the nested tuple. So what I will do, first of all, I'll create a simple list of it, right? So I'll do list is equal to nested underscore tuple, right? So this will give me a list of whatever values I have present. Now if I just print list just to check if I'm getting what I want. Yeah. So now when this list is created, now I what I need to do, I need to put a while condition. Now remember, till when we are going to put the while condition, till my, because I'm doing pop element, I'm removing elements, I'm popping out elements from this list, right? Till this list becomes empty, technically, right? So what I will be doing, while list is true, so basically it is existing, right, while it is there. So what I'm going to do, I'll do a current basically, which is equal to list dot pop. So I'm picking up the last element, the pop element I'm picking up from this list. Okay, now once this is done, what I need to check, I need to first of all check if it is a tuple. So what I will do, if type of current is equal to tuple. So if it is a tuple, then I'll move forward. Okay, if it is a tuple, I'll move forward. Now let us say so now what I need to do for this current which we have picked, which we have basically picked, let's say this element. So let's say there is multiple elements inside it. Let's say we picked this one. Now there are multiple elements inside it. So if we do for item in current, okay, there are multiple items for item in current. If we do so what I need to check that okay, so first of all I got it as tuple if type, if yeah, okay. Now if again I'll do if type of item is tuple. So basically this is telling me if I'm picking up tuple inside tuple. So if I'm picking those type of things, if type is equal to tuple first of all, and again if length of this item, basically if length of this item is 2, because I'm just now checking for the simple tuples here. Okay, now if length of this item is equal to 2, and also that the I'll say type, when I do item first element, it has to be an integer, because I'm just, so basically I'm using this condition to validate that I'm actually at as individual tuple level. Otherwise this won't make sense. Okay, so if type of item 1, if it is equal to int, this is an integer for me. Okay, so what I will do, let's say name comma salary, I assign this to my item here. So now my this will be assigned a name, this will be assigned a salary. That's what I'm going to do. Now I put my if condition that if salary is greater than, let's say 70,000, I have to just print a name. So print name. So this becomes my first block of code. Now what if this was not so basically I see that, okay, what if this was not a tuple, like tuple like this, simple tuple. So what I have to do, I have to append it back to my list. Okay, so that's what I have been doing. So else I'll say list dot append, and by appending I will just pass the item. Okay, and now if I do a print of, let us say I want okay, so I have list append dot item. So yeah, I just want to print name, which I'm doing here. Okay, that's fine. Now I think this will do it. Let's see what it comes. So it is giving me Ivy, Grace and Eve. So this is what this particular question is about. That's the structure is this only that we did here. First of all, you pop an element out. You pop an element out from here. You check if it is a tuple. If it is a tuple, there are two possible scenarios. It can be a simple tuple, it can be a complex tuple. If it is a simple tuple, how do you check that? You check the length as 2 and you check the type of second element as integer. If that is the case, you assign name and salary and you put, if salary is greater than 70k, you print name. And if it is a complex tuple, you add it back to this. And if you do keep on doing iteratively, it will eventually boil down to a simple tuple. So I think this was the solution to this. I know this is little complicated. It will, but try to visualize that architecture diagram that I explained. It will be easy for you guys to understand it. But I mean, just keep this in mind. Practice a couple of more questions like this, so it will help you. Question 4 was on similar line. Question 8 was also on similar lines. So coming to question 9, now if you see question 9 is exactly again a similar. You to use a dictionary comprehension, extract and print the name of cities where population greater than 3 lakh. So it is exactly the similar question that we did earlier, where question number 8 or question number 4. So you should try this on your own. I don't want to spoon feed every question, to be honest, but this is exactly similar question. If you can solve question number 8 or question number 4 and this list comprehension question that I gave earlier, it is pretty on the same line. You need to know how to access complex things inside a dictionary and you'll be able to solve it. So I'll move to question number 10 now. So let's solve the last question for this assignment. That is I think this is the pretty easy question actually. Write a Python program that takes a list of integers as input. So basically it is taking list of integers. So it sorts the list in descending order and returns a list containing only the distinct elements. So it's a pretty simple. So it has a couple of operations that we need to do. So what we do, first of all, we have this list ARR equal to something like this. Sort in descending order. So how do we sort in descending order? Any list, it is ARR dot sort and it's wanted descending. So we'll say reverse equal to true. Okay. Now if I do print ARR, so what do I get? So you see 554. So I have sorted now and I have basically sorted in the descending order. So now what they're asking me that distinct elements. So they only want the distinct elements. So a way to get distinct elements is to convert that list into a set. So what we do, that distinct is equal to set and we provide ARR name. Okay. And now if I print distinct, so I'll see that this is converted into distinct elements and these are in a set. Now what I need to do, convert this back to a list. So what I will do basically, that final list is equal to list and I'll just pass distinct and I'll just print final list. So I've got my final list. So this is basically all the distinct elements present inside the list. So you just need to convert them into a set. So these were all the 10 questions that we discussed. I mean, I know these were few of the difficult questions, to be honest, but my main objective is that you try to understand whenever you hear any difficult question, you build the architecture and then start coding. I just focus on this only. Building architecture will take time. It will not happen instantly, but when you practice, when you practice like 100 200 questions, right, then you will start understanding the intuition that okay, what type of question is this, what type of things are they expecting. So that thing can be learned over time. Main thing is to practice regularly, do the daily assignments, do the weekly tests, weekend tests, weekend quizzes, and you should be good to go. So thanks a lot for watching the video, for giving the test. I'm looking forward to see you guys in the future classes, and thanks a lot again.